guys, Mr. G here, and we're going to be doing a video today on a test, and this time it's going to be organic chemistry. We've done momentum, we've done projectile, we've done Newton's law. Now we're going to do organic, and also we're going to divide it in two parts, okay? So we're going to start with this question 1, which is, as usual, a multiple choice. The first one says, which one of the following compound is an alkane? And they give you the molecular formula of different compounds. So my suggestion is to get the general formula for alkane, which is CnH2n plus 2, and then start trying with them. So if, for instance, if you have 4 carbons, then you should have 2 times 4 is 8 plus 2 is 10. So you should have 10. So if you have 4 carbon, you should have 10 hydrogen. Okay, that one was quite easy. It matches with the first one. So the correct answer is 8. But let's say, for instance, you try the second one. So if you have 2 carbon, you should have, to be an alkane, you should have 2 times 2 is 4 plus 2. So 2 H, 4 plus 2 is 6. So the second one is not an alkane. Okay? And you'll do that one with the rest of them. But that one is the answer. The first one, the answer is A. Quite simple. The second one, consider the following structural formula of an organic compound. Which one of the following is the correct IUPAC name of the compound? And they give you different options. But we're going to write the name, and then obviously the name will match with one of them. But we're going to follow the steps. The first one is to find the homologous series. So the homologous series in this case is an alkane, and therefore it will end in ane. Second step is looking for the longest continuous carbon chain, and here you have two options that you can clearly see that they are long. So one of them is when you go straight and do here, for instance. In that case you have 1, 2, 3, 4, 5, 6 carbon. In this case you have 6 carbon. And the other option is to turn here down, and then in this case you have 1, 2, 3, 4 and 5. So 6 is the longest one, and therefore we are going to take 6, the straight one. That one is the one we're taking. Okay, so 6 is hex, just to follow the step. 6 is hex. So we have it end in ane and have a hex. Now we're going to identify any substituent. And here you can see that you have a methyl, that is a methyl. And we're going to give numbers to the carbon starting from the n nearest to the substituent. So carbon 1 is this one, 2, 3, 4, 5 and 6. Therefore the methyl is in carbon 4, and we write here 3 methyl is in carbon 3 methyl. So the name is going to be 3 methyl hexane. Hexane. That is the correct number, and it matches with C. So C is the correct answer for 1.2. Let's go to the other question here. Which one of the following is a condensed structural formula of the ester propyl ethanoate? So the ester they're giving us, I'm going to write it here. Propyl ethanoate. Now I want you to note and recall from the formation of ester or esterification. This one is coming from alcohol. This is coming from the alcohol. So in other words, the alcohol that was used here was propan-1-ol or propanol. Okay, that is important. And this part here will have the prop is 3, so it will have 3 carbons and the oxygen. That one is the part that is coming from the alcohol. Okay, like this. But in this case it's condensed, but it doesn't really matter. I just want to show you. Okay, So, and now these are the part that you can see on that side, the ethanoate. This ethanoate is coming from the carboxylic acid. This is not the carboxylic acid, this one is coming from the carboxylic acid. And in this case will be the part that have double bond O with another carbon because it's 2 carbons. So this combination will give you the ester. So this is what we are looking. The side that have the O must have 3 carbons, and the side that have the double bond with O must have 2 carbons. And if we look at that, then you can see that the answer is going to be B. You have here 3 carbons with the oxygen, with a single oxygen, and 2 carbons with a double bond. So this is the ester we are looking for. Let's go to the other part of the multiple choice. Which one of the following compound is an isomer? There's a video for isomer. I'll try to give you the link of the compound given below. And then you have this compound given below. Remember, isomers have different structure and they have the same molecular formula. So in this case, this one is an alkene. So the isomer must be another alkene. So the options are either B or C. Okay, but now we are looking for an alkene that has 4 carbons, 1, 2, 3, and 4 carbons, and then it have 8 hydrogen. That is what we are looking for. We're looking for any alkene. It must be an alkene. It must be an alkene that have the same number of carbon and hydrogen. Now, prop 1 in, prop is 3 carbon. Okay, prop is 3 carbon. So prop cannot be. But is 4 carbon. So it must be but 1 in. This one is the correct answer. But 1 in. Now, what type of isomers are those? In this case, this is a positional isomer. Why? Because the position changed. You can see here, this one was 2 and now here moved to 1. So the double bond changed the position. So the correct answer is C. I hope it's clear. And the last multiple choice is which one of the following alcohols given below has the strongest intermolecular force? And this one is quite simple. Which one of the following alcohols gives the strongest intermolecular force? And you can see that they're starting from 1 carbon, 2 carbon, 3, and 4. So the longer the chain, the stronger the intermolecular forces it will be, because it have a greater surface area and more side for London forces and the intermolecular forces in this case. So thank you guys. This is question 1.5. Let's go to question 2, and it's going to be the last question of this video. They say the letters A to F is a table below represent 6 organic compounds. Now I personally, when I do this, I tell my learners to identify the compound. You can see that A is an alcohol. You can see that B is an aldehyde. You can see that C is a carboxylic acid. I like to do this one because it will help you. This one is a ketone. How do I identify? You can see the name or you can see the functional group. In the case of the alcohol, you can see here the functional group. In the case of aldehyde, here is the functional group. Carboxylic acid is oic acid, and this one is ending in on. Now E is going to be another aldehyde. Another aldehyde, you can see the functional group. And then the last one is an alkene. An alkene, you can see here the functional group. So that is the first thing I'll do, guys. If I was a learner, I'll do this one all the time just before answering the question. Now let's go. Use the information in the table to answer the following question. Name the alkyl group present in compound A. So in compound A, which is an alcohol, they don't want to name the compound, they want to name the alkyl group. So to do that, we have to identify the alkyl group. If you go straight forward, you have 1, 2, 3, 4, and 5 carbon. If you go up, you have 1, 2, 3, 4, and 5 carbons. So either way, you have 5 carbons. So one of them must be an alkyl group. And in this case, the alkyl group is here. You can see it here. This is the alkyl group, and is going to be ethyl. Ethyl is the alkyl group in this case. That is the question. So I'm going to write the answer right here next to the question. Is ethyl. That is the question. Second one, name the functional group present in compound A. Now in compound A, we're still with the alcohol. Compound A, this is the functional group, and this functional group has a name, that is hydroxyl. Hydroxyl, please. That is very simple. Name the functional group. Be careful, because people don't just read, they stop reading, or learners, let's say, they stop reading halfway and then they don't complete the question. This is hydroxyl. Hydroxyl, that is the name of the functional group. Write down the IUPAC name of compound B. Now we have to go to compound B here. Okay, and this one have different steps. Remember, I told you to please follow the steps. So let's write this right down here, because I want to follow the steps, and I'll be back just now. Okay, so here it is. We are going to write the name for this one. There is a video also naming. I will leave the link if possible here. So it's fine. What is the first step? The first step is to identify the homology series. Here is the homology series. We said this an aldehyde, and therefore we'll finish in al. That is important. Second step, we're going to look for the longest continuous carbon chain. This one is quite simple. It's straightforward. You can see it there. Now be careful. Here people attempt to confuse this one there with an alkyl, and it is not an alkyl group. Alkyl groups cannot be in the last carbon, guys. Okay? So in this case, we have 1, 2, 3, 4, 5, and 6 carbon, and this 4 is going to be hex. But I said also in the naming compound videos, when you have from alcohol onward, you must have the AN, so it's going to be hexane. The AN here is important, so make sure you add the AN there. Now we're going to count the carbons starting from the carbon nearest to the functional group. In this case, it's the first carbon. It's 1, 2, 3, 4, 5, and 6. We have 6 carbon in that specific order. Now we are going to identify the alkyl group or substituents, and I'm going to write it here. This is the steps I follow. This is 3-methyl. This one is 5-methyl, and this one is 5-methyl. So how do you write these substituents? It will be 3, 5, 5 trimethyl. And then the rest is just combining everything we have. So the final name of the compound will be 3, 5, 5 trimethyl hexane hexanal. That is the name, saying together. 3, 5, 5 trimethyl hexanal. That is the name of the compound, guys. I hope you understand. It's not that bad. Let's go to the next one. The next one say, write down the structural formula of compound D. And now we have compound D is 2-methyl pentan 3-on. Let's do it down here, guys. Let's do it down here. Here we are now. When we're doing this question, which is now from the name, writing the formula, it's very simple. All you have to do first is to look for the name of the number of carbons. We have pent, and pent is going to be 5. So I'm going to place 5 carbons straight forward. 1, 2, 3, 4, and 5. And I'm not going to combine those carbons yet. Second step, I'm going to look for the functional group. This is a ketone. And if I start counting from left, I'm always start from left. This is carbon 1, 2, and 3. In carbon 3, there is the functional group of ketone. Then I combine the carbons. Only then. I didn't combine before because sometimes it's an alkene, that's why. So now I'm going to place the methyl in the second carbon, which is here, structural. Make sure everything is structural. And guys, that's it. The rest is complete the hydrogens, and to make sure everything has 4 bonds, not 5, no 2, no 1. All the carbons must have 4 bonds. Here you can see it's 1, 2, 3, and 4. So each of them has 4 bonds, and this one is the structural formula. If you start from right to left, this is the same compound, guys. It is exactly the same compound. It does not really matter. I like to start like this, but it's optional. Now that is question 2.4. 2.6. Which one of the two compounds are functional isomer? Now, functional isomer, we are looking for 2 different combinations. I am also going to leave the link about that, but we're looking for aldehyde can be a functional isomer of ketone, and esters can be functional isomer of carboxylic acid, or vice versa. In this table, when we identify, there is not any ester. So the only 2 combinations are aldehyde and ketone. So we have 2 aldehydes and we have 1 ketone. Now this ketone that we have here, that we just write the structural formula, we have a ketone that have 6 carbons, 12 hydrogens, and 1 oxygen. So we are looking for an aldehyde that has also 6 carbon, and obviously will have 12 hydrogen and 1 hydrogen. This one here that we write the name, if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon. So it cannot be this compound. So it must be the other aldehyde. In this case, 1, 2, 3, 4, 5, and 6 will be compound E. E also has 6 carbon and 6 and how many hydrogens I said? 12 hydrogen, guys. So 6 carbon and 12 hydrogen. So in this case, the 2 functional isomers are compound E and the ketone, which is compound D. I hope you understand, guys. I'll leave the link for the isomers. It could be very tricky, but it's one video on its own. Compound 2.3. Compound C react with an alcohol. So C, compound C, which is a carboxylic acid here, you can see it, react with an alcohol. Okay, obvious. You can see carboxylic acid with alcohol and ester will form. Write down the IUPAC name of the alcohol mentioned in question. No, pardon. Compound C react with an alcohol containing 2 carbons atoms to form an ester and an inorganic product. Write down the name of the alcohol mentioned. Alcohol with 2 carbons is going to be ethanol. That's it. Nothing to say. It's quite simple. The answer here is ethanol. You don't have to write ethan 1 all, because in either side is going to be 1. Ethanol. Using structural formula, write down the valence equation for the formation that takes place in question 2.6. We have ethanol and we have butanoic acid. So we are going to answer that one real fast. So we have an alcohol, which is ethanol. Guys, ethanol is 1 carbon, 2 carbon, oxygen, and H. This is the structural formula of ethanol. The way of where do you place the OH, it doesn't really matter. If you start with butanol, with the acid, or you start with alcohol, it does not really matter. It's up to you. Now I'm going to add the butanoic acid. I'm going to start with the functional group, but this is entirely up to you. Where do you want to place the functional group? Is not really a change anything. So it's 1 carbon. That is the first carbon. 1, 2, 3, and 4, and this is butanoic acid. Okay, now this is going to be in the test. There is always a question on this is hydrogen, it looks like nitrogen. It is always a question like this in the test. Now here you have the arrow. Here you have the arrow. Obvious, you can see that's not fit, so I'm going to do it down, but you can see the arrow. Okay, so it must be in a line. Note that during esterification, H2 SO4 was used, and that one was concentrated sulfuric acid that act as the dehydrating agent and as a catalyst. So what is the ester going to be? The 2 carbons of hydrogen of alcohol, O, combined now with the 4 carbons of the butanoic acid. And here is the O. So this one is the ester. But remember, ester is not the only product. There is also water that must be represented. Now water, I'm going to represent it also with a structural formula, but I don't know if it must be in a structural formula. I don't know how they're going to mark this work. I will do it in a structural formula, H O H. Okay, this one is the arrow, that black arrow there. So this one is the esterification formation, guys. It's quite simple. There's also a video just for this one. I will leave the link. There's a video just for esterification. It's not that bad. Then write down the IUPAC name of the ester form and write 2 conditions needed for the preparation of the ester. We're going to finish quickly here. The name, remember the alcohol first, so this coming first in the name, and this one will come ethyl, and then the second part of the carboxylic acid there for second, and that one is the butanoic acid, so it will come butanoate. So ethyl, butanoate. Once more, I have a video on this one. I leave the link. Try to watch it, guys, because esterification is a video on its own. So ethyl butanoate is the answer for this question here. I'm going to write it here. Ethyl butanoate, that is the answer. And then write 2 conditions. The first one is that you need H2SO4, as I said. It's going to be using this one as a catalyst and also as dehydrating agent. And the other ones, you need heating in a water bath. In a water bath. Now why? Because all these reactants, reagents, products, they are flammable. So you can see ethanol is flammable. The carboxylic acid may also be flammable, and the ester. So it cannot be in an open flame, guys. So that is why heating in a water bath. I don't know if you know what water bath is. My learners did struggle to understand. This one is when you boil inside a place where there's water. So you are not boiling or heating straight into the flame. And guys, this is the question. We are done with this first question. We are going to do questions 3 and 4 next time. Thank you for watching. I hope it helped. You can go back, watch the other videos that can help you to solve some of these problems. I see you next time. Mr. G here.